Hello, in this session, we're going to take a look at SAT quadratics. Now, we won't be looking at everything related to SAT quadratics, but just some of the stuff that shows up on SAT questions that tend to be advanced within the category of quadratic equations. Specifically, we're going to take a look at SAT questions involving something known as the discriminant. Let's begin by taking a look at a question and giving you an opportunity to try it on your own. So feel free to pause this video and give yourself maybe 90 seconds to try this question on your own. Now that you've had an opportunity to try this question on your own, let's go ahead and take a look at it together. All right, so the question starts off by giving you this quadratic equation. It's set equal to 0, but you're not really able to solve for x here because you've got this variable b. All right, so let's see what the question is asking us for. It says in the given equation, b is a constant. For which of the following values of b? Okay, so it's actually asking us to solve for a possible value of b, but there's more information if we keep reading. Will the equation have more than one real solution? And this last part here, that the equation will have more than one real solution, is the most important part to beginning the question. And the reason for that is that when you're dealing with quadratic equations and you are told that the quadratic equation has a certain number of possible solutions, what that means is you need to use the discriminant. And when you have a quadratic equation in which you're told that it's going to have more than one real solution, the discriminant must be positive. Okay? So again, if you have an equation in which a quadratic equation in which you're going to have more than one real solution, the discriminant must be positive. Now, for something to be positive, that means it must be greater than 0. So what we should do is let's write down the discriminant and say that it's got to be greater than 0. And this is the discriminant right here, b squared minus 4ac. So what we'll do is we're going to take some numbers from this equation and plug them into this inequality down here. So first off, we've got b squared down here in the discriminant. Well, there's a b up here already, so we'll leave this b alone. This b is just this b. Okay, now it says minus 4ac. Well, what's a? Well, in the standard form of a quadratic equation, a is the coefficient of x squared. So let's go up here and look for x squared. We have x squared right here. The coefficient of x squared is 64. So down here in this inequality, a is going to equal 64. Now let's try to figure out what c is. C is going to be the entire part of the expression that has no x. Okay, well, there's an x here, x squared. There's an x here, x to the first power. If you look here, there's no x. Okay, and we're talking about the left side of the equation, the part that, is set equal to 0. We're not looking over here. All right, so over here, we have no x. So c must equal 25 because 25 has no x on it. All right, so we're going to take a equals 64 and c equals 25 and plug it in right here. Okay, so now let's simplify this. We're going to do negative 4 times 64 times 25. You could use your calculator. That's going to give you b squared minus 6400 is greater than 0. All right, so to simplify this, let's take this negative 6400 and let's add it to the other side. So we get b squared is greater than 6400. So now to solve for b, we're going to take the square root of b squared, which is b, and the square root of 6400. Okay, so the square root of 6400 is b, but if we look here, right, this says b is greater than 80. None of these answer choices are greater than 80. Well, what's going on here? Okay, well, the issue is that 80 squared equals 6400, but so does negative 80 squared. So we have to account for negative 80 squared. Now, when you negate an inequality, like you divide an inequality by a negative number or multiply an inequality by a negative number, you have to reverse the sign. So when we take the square root of this b squared and put negative 80 here, right, like here, we're going to actually change this from a greater than to a less than. So another possible solution to this inequality is that b is less than negative 80. Let's check whether there's an answer choice that is less than negative 80. Well, yeah, there is. Answer choice A is less than negative 80. And so this must be the correct answer to the question. Okay, so great work. So now let's just quickly recap what are some of the topics we need to master in order to answer a question like this on the SAT. So first, we need to know about the standard form of a quadratic. And so the standard form of a quadratic is y equals ax squared plus bx plus c, where y equals 0. Okay, so you can see here we have equals 0, and then we have an ax squared plus a bx plus a c. And so you just have to be familiar with the standard form of a quadratic. And the reason for this question that we need to be familiar with the standard form of a quadratic is so that when we use the discriminant, remember, which is b squared minus 4ac, we know what our a will be, we know what our b will be, and we know what our c will be. A will be the coefficient of x squared, b will be whatever is the coefficient of x to the first power, and c will be whatever part of the equation simply has no x on it. Okay? All right, so let's try to apply some of this to another question. All right, so just like the previous question, pause this video and give yourself about 90 seconds to give this question a shot. All right, now that you've had a chance to try this question on your own, let's go ahead and take a look at it together. The first thing you want to notice is that you have a square root symbol on this side of the equation. And when you have a square root symbol on one side of the equation, something you want to at least consider doing is that at some point you might square both sides of the equation to get rid of that square root symbol. Before we do that though, let's take a brief read of the question and see what it's asking for, what information it gives us. So the question says, in the given equation, k is a constant. The equation has exactly one solution. Okay, so now we're seeing this thing about the number of solutions again. And so where it says that the equation has exactly one solution, that's a clue to us that we're going to need to use the discriminant. Now, when an equation has more than one solution, a quadratic equation has more than one solution, the discriminant needs to be positive, greater than 0. But if it has exactly one solution, then the discriminant must equal 0, not be greater than 0, not be less than 0, but exactly equal to 0. So the first step here is to write down that the discriminant must equal 0. Okay, so we have our b squared minus 4ac equals 0. And so now we need to rewrite this equation in the standard form of a quadratic so that we can clearly see what our b is, what our a is, and what our c is. So let's go ahead and let's do that. All right, so to do that, we are going to square both sides. So let's go ahead and do that. So by squaring this left side, the square root symbol goes away, as you can see down here. And then here you'll notice that I have squared the right side of this equation. Okay, so now this 58 minus x in parentheses squared, you can't just distribute the square here. So it's not just 58 squared minus x squared, because if you were to write this out, this would be 58 minus x times 58 minus x. So when you do that out, what you're actually going to get is you're going to get 58 squared minus 2 times 58 times x plus x squared. All right, so now you can use your calculator to do 58 times 58 and then 2 times 58. And so what you're going to get is k minus x, just bringing that down, is equal to 3,364 minus 116x plus x squared. Okay, now let's recall that we need to figure out what the values are for the discriminant, what the b is in this discriminant, what the a is, and what the c are. And so in order to do that, we need to take this quadratic that we now have down here and put it in the standard form of a quadratic. To do so, we want to set this quadratic equal to 0. To set this equal to 0, we need to minus this k over here, and we need to add this x to this side as well. All right, so minusing the k, there's nothing here with the k, so the k is just going to come over here. And then when we add the x, it's going to combine with this negative 116x to give us negative 115x. And as you can see, we brought the k over here, and so to bring it over here, we just subtracted it to this side. Okay, so now we have this quadratic that's equal to 0. Okay, so now let's take our values from this quadratic and plug it into the discriminant. Okay, so the first value that we might find is the value of a. And so just because I'm going in alphabetical order. So a is always going to be the coefficient of your x squared. So here's x squared. And the coefficient of this x squared here, it's a 1. Nobody really writes that down usually, but it's a 1. So we'll say a equals 1. Okay, now in the discriminant, b is whatever in the quadratic is the coefficient of your x to the first power. So if you look here, the coefficient of x to the first power is negative 115. Okay, and then c in the standard form of a quadratic is going to be whatever doesn't have an x. So here, this 3364 doesn't have an x, and neither does this negative k. So c actually equals this whole thing here, 3364 minus k. So we're going to take this a equals 1, this b equals negative 115, and this c equals 3364 minus k, and plug it into the discriminant up here. And so you can look over here on the right, we've just done that. Okay, So now take a calculator and do 115 times 115 or 115 squared, and that's going to give you 13,225. And take a calculator and do 4 times 1 times 3,664, and that's going to give you this 13,456. And then we're also going to distribute this -4, right? -4 times 1 is -4. And so we're going to take this -4 times this -k, and -4 times -k is positive 4k. Okay, so let's combine like terms here. So this 13,225 minus this 13,456, just put in your calculator, is going to give you -231. All right, let's add this -231 over to this side, so we get 4k equals 231. Now at this point you could divide by 4, but take a quick look at the end of the question. It's asking us, follow my arrow, what is the minimum possible value of 4k? So the question is actually asking us to solve for 4k. Well, we have 4k right here. It equals 231. So this is the answer to the question. Now, in terms of what you need to know in order to answer questions like this, it's very similar to the previous question. You need to know the standard form of a quadratic so that in your discriminant, you know what b is, you know what a is, and you know what c is. Okay, so a is going to be the coefficient of x squared, b is going to be the coefficient of x, and c is going to be the entire part of the quadratic that has no x component. But this will be true if this quadratic equals 0. So you can see here where my arrow is, we had to simplify it, and then once it was simplified, make sure it was set equal to 0 before we found our values of a, b, and c. And then the second thing is we need to know about the discriminant. We need to know, one, what the discriminant is. It's b squared minus 4ac. The other thing we need to know is that if the quadratic has exactly one solution, the discriminant must equal 0. On the previous question, we learned that if a quadratic has more than one solution, then the discriminant has to be greater than 0.